Let's now study again some of the examples and decide whether they are the sets or not. Okay, we have to identify whether they are the sets or not. Okay, so yes, we have to decide whether they are the set or not. Let us consider the first example: prime factors of the 210 number. Okay, so factors of this 210 number, we have to first of all look at the factors of the 210, and out of that all the factors we have to consider only the prime factors. Okay, the factors of the 210 are 1 obviously, 2, 3, 5, 6, 7, then the 10, 14, 15, 21, 30, 35, 42, 70, 105 and 210. So these are all the factors of this particular number 210 number, but we are interested in the prime factors only. So the prime factors, prime numbers starting from the 2. So 2 is a prime factor, 3 is a prime factor, I think 5 is also the prime factor, then 6 is not the prime factor. Okay, then the 7 is the prime factor, 10, 14, 15, 21, 30, 35, 42, 70, 105 and 210, these are not the prime factors. So it means that this particular collection prime factors, these are all the factors of this particular number, but the prime factors are 2, 3, 5 and the 7, right? So these are the prime factors of 210 number. So it has the well defined set of the objects, so it is a set. So second is that the first 5 natural numbers, the first 5 natural numbers, so we know that the natural numbers are starting from the 1. So the first 5 natural numbers are 1, 2, 3, 4 and 5. If you ask this question to any of your friend, so they will enlist this particular 5 numbers, so it is a set. Next is all the natural numbers less than the 10. So the natural numbers are starting from the 1, 2, 3, 4, 5 and we want the natural numbers which are less than the 100, means up to the 99. Okay, so it is a well defined collection of the objects, so it is a set. Odd natural numbers less than the 10 means the 9 and they are starting from 1. 1 is the natural number and it is the odd. 2 is the natural number but it is the even. So 3, 4, 5, 6, 7, 8 and 9. So these are the odd natural numbers which are less than the 10, right? So it is a set. Collection of all even integer numbers. So integer numbers are starting from collection of all even integer numbers. So integer numbers, it means that they are starting from minus infinity to minus 4, minus 3, then the minus 2, minus 1, then the 0, 1, 2, 3. In positive side also they are expanding in upper direction, but we want the collection of the even integer numbers only. So 2 will be there, then the 4 we will consider, 5 not, it is a 6, like that. So this particular collection will include the 2, 4, then the 6, 8, 10, 12 and like this. So it is an infinite series. Okay, so again it is infinite but the objects are definite. Okay, objects are well defined, so it is a set. Next, collection of all odd integer numbers, so they are 1, 3, then the 5, 7, 9, 11, 13 and like that. They are infinite but having the definite objects, so it is a set. Next example is the collection of all integer numbers. So they are having this particular range. All the negative numbers, say minus 2, minus 3, minus 2, minus 1, 0, then 1, 2, 3, and they are expanding in positive direction also, and they are expanding in negative direction also. Okay, minus infinity to plus infinity. So objects are well defined, so it is a set. So, and these are the objects of this particular set. Collection of all positive integer numbers. So positive integer numbers are starting from 1, 2, 3, 4, 5, 6, and like that. Collection of all negative integer numbers. So minus 3, minus 2, minus 1, and in negative side all the integer numbers. So it is also the collection, it is also the set, it is also the set. The collection of all the questions in this particular chapter. In any of the chapters, the number of questions are finite and fixed and definite, well defined. Okay, so yes, it is also the set. The days in a week. So in a week there are 7 days. Okay, 7 days. Which are those? Then the Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay, these are the days in a week. So they are fixed. So it is a set. Okay, so like this we have seen some of the examples, and we have identified whether these particular examples, whether these particular collections are called as a set or not the set. Okay, now some symbols are there, and these symbols are specially used to represent that particular set. For example, suppose that the set of the natural numbers. So we know that the natural numbers are starting from the 1, 2, 3, 4, 5, 6, 7, and all that particular. To represent this particular collection, which is a set, we use the symbol capital N. Okay, then the whole number means if you are starting the numbers from the 0, 1, 2, 3, 4, 5, and like that. So it is called as a whole number. The difference between the natural number and whole number is that 0 is extra here in a whole number. So set of all integer numbers. So it is represented by the Z symbol. It is represented by the W symbol. So these are the standard symbols in a mathematics. So we have to use that particular symbol whenever we are dealing with that particular set. Okay, so the set of all integer numbers. So integer number means all the negative numbers, means it is starting from minus infinity to plus infinity, means all the numbers are called as a integer numbers, like this. Now the rational numbers means the numbers which can be represented in the form of the p by q is called as a rational number. For example, 4 is there, so 4 can be represented as 8 by 2, so it is a rational number. Okay, so like that particular rational numbers are represented by using the q symbol, capital Q symbol. Irrational numbers, the numbers which cannot be represented in p by q form, is called as irrational numbers, such as square root of the 2, square root of the 3, then value of the pi, okay, which is the diameter divided by the circumference of the circle. So these particular values are called as the irrational numbers. These particular numbers are called as the irrational numbers. So that particular set of all these particular numbers is represented by using the q dash. The real numbers, so we know that the rational numbers plus irrational numbers are collectively called as a real numbers. Okay, so like this, so we have that particular representation using the capital R. Set of all positive integer numbers means this particular range, positive integer numbers and the negative integer numbers. So this is called as a positive integer numbers. and this is called as a negative integer numbers. So all the positive integer numbers is represented by z plus. So 1, 2, 3 and like that. So all positive rational numbers are represented by q plus. All positive real numbers are represented by the r plus. So these are some of the symbols, so we have to just remember that. So natural numbers, they are starting from the n, so we can remember it. Whole number w, integer number we have to remember it by the z. Rational numbers means the number which can be represented in the form of the q by p by q. So q, then q dash is irrational numbers, complement like that. Real number means the capital R. Positive integer numbers means the z plus. Positive rational numbers means it is a q plus, and the positive real number means it is a r plus. So these are some of the English symbols which are used to represent the set. So now the symbols are used, English like symbols, in a capital letter and in the italic form. These are used to represent the particular set. So these are the standard ones. All these are the standard functions, standard sets. Okay, so these are the standard sets. So throughout this particular course we are going to use this particular standard sets. Now to represent a set. To represent a set, suppose there is a set of the three colors, okay, say red, green and the blue. So this is a collection of the three primitive colors, red, green and the blue. So if I want to represent this particular collection as a set, so I know that it is a set, or the set number, example of the set is collection of the days in a week, say. Okay, so how many days are there? Sunday, then the Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. These are the 7 days in a week. So to represent a set in a mathematics, we have to use the curly brackets. So we have to keep all these particular elements of that particular set within a curly brackets. Every element is separated by using the comma, and we have to assign a single name to this particular set. So this is achieved using the capital English letters and equal to sign. So the sets are represented by using the capital letters in italic forms, such as A, B, C, D. We have to use these particular capital letters here, right? And the elements of the set, these are the elements of the set which are written in a pair of the curly brackets, and each element is separated by the comma. So this is what the representation of this particular set. If I want to create this particular set, say color set, then I have to use this particular representation. Now we will learn what is mean by the belongs to, means epsilon symbol is used, belongs to and not belongs to symbol. So this means it is called as a belongs to. This is called as a belongs to, and it is called as a not belongs to. So in a mathematics, okay. So what is mean by this particular, okay? Say there is a set B, and in this particular set B there are 4 elements, 4, 2, 1 and the 4, 2, 1 and 3. These are the 4 elements in that particular set B. Now we know that 4 is an element of the set B. So we say that the 4 belongs to the set B, and this is what representation of that particular mathematically. So mathematically it is represented that 4 belongs to the set B. Like that, the 2 belongs to the set B, 1 also belongs to the set B. 3 also belongs to the set B. But the 8 does not belong to the set B. 10 does not belong to the set B. Right? 5 does not belong to the set B. 99 does not belong to the set B, like this. It is belongs to symbol and it is not belongs to the symbol. Okay, it is the epsilon. It is a Greek word that we know. So that particular Greek symbol epsilon is used to represent whether that particular elements of the set is belonging to that particular set or not. Suppose that there is a set V. Okay, so that particular set V is the set of the vowels in English alphabets, that is a E, I, O, U. Now it makes the sense that to give a particular name to the set, we have to give the meaningful name to that particular set. It is a convention, not the rule. So every element of this particular set is a vowel. So I represent that particular set using the V, capital V symbol. So how to use the epsilon symbol to represent whether the element belongs to the set V or not. So A is there and A belongs to V. B does not belongs to V. C does not belongs to the V. D does not belongs to the V. E belongs to V. So like this. So we have to use this epsilon symbol to suggest whether the particular element belongs to that particular set or not. Now we have to use the epsilon symbol like this. 0 belongs to the W and 0 does not belongs to the N. So what is the meaning of this particular? 0 belongs to the set of the whole number. Okay, W means set of the whole number. So 0 belongs to set of the whole number and the 0 does not belong to the natural number set of the natural numbers. So 0 belongs to the whole number and 0 does not belongs to the natural number. So these two particular statements are represented in a mathematics like this, in this particular way. Okay, we will learn what is meant by the roster form of representation of the set. Okay, so roster form, the form of the set representation that we have seen earlier is called as the roster representation of the set. In this particular form, the capital A is a symbol. Symbol is written first of all, then equal to sign, and within a curly bracket we have to write down the elements of that particular set. So this form of the representation of the set is called as a roster form of that particular representation of the set. Suppose that I have to write down a set of the alphabets, a set of the vowels in English alphabets. Okay, so V is equal to A, E, I, O, U. These are the different alphabets from the different vowels from the English alphabets. So if I create one more set, suppose A, if I have one more set, suppose A, then okay, so I can also write down the same set V as like this also, I O U E A. So if I interchange the position of these particular elements of the set, then that exchange of the position will not matter here. Okay, so ultimately the 5 elements are there, here also the 5 elements are there, A, E, I, O, U. So 5 elements are there, 5 elements of there. So ordering of the element is irrelevant in a set. Okay, so it is important one.